Hi everyone. So let's check out like a 2D density problem, if I can remember what we're working on. So in this problem, we have an oil well that's basically like the center of our picture. And it's burning and we're getting soot and ash and whatever, what did I call it? Sediment that goes up into the air and then comes down and settles on the ground. And basically the way this is working is that closer to the well, it's a lot thicker. And then as you get further from the well, you get less of this sediment built up on the ground. And we're trying to figure out the total amount of sediment within 100 miles of the well. So this function right here is what tells us if you're a specific distance r, so I'll say an r sub I, from the center of the picture, the oil well, how much sediment is there per unit area, so per square mile in this one. So this thing, the bigger R is, the smaller that is, and that's where I'm getting this idea of nearby the oil well, you have a lot more sediment built up on the ground than further away. Plus that sort of makes sense in my head anyways. So always the idea in these problems is trying to slice so that you get constant density. And in this case, the way to get constant density is to always be the same distance from the oil well, which means your slices are really going to be circles. But it can't just be this one circle. It has to have some area to it. Since this is tons per square mile, we need to multiply by the number of square miles. We need to multiply by an area if we just want to end up with tons of amount of sediment. So what we're going to do is we're just going to give our slice, try not to make this too ugly, a little bit of thickness. So we're slicing out this little skinny circular like washer, I guess is what we called them, or yeah, you guys have looked at washers at some point. So washers is what we call them in the last section. But we're going to approach this a little differently. Instead of taking like outer circle minus inner circle, which a lot of times people will be in that frame of mind from the last section, we're going to say, well, really, this is so skinny that we could just imagine making a little cut here and kind of unrolling that. And it's basically just a really long, skinny rectangle that we've sliced out. There's kind of a little slant to that, but it's negligible if your slice is infinitely skinny. So this, let me pick up some colors. This right here becomes this height of our little strip, and that's really just a delta R. We start with some smaller radius and we move out to some very slightly larger radius, and that's an infinitely small change in R, which is going to be our delta R. Going the other direction, if we want to figure out how long this is, that came from taking this whole circle and unrolling it, which is basically just the circumference of your circle. So the width here is going to be 2 pi times whatever radius you're at. And again, you're hitting a couple of them, but it's such an infinitely small range in R's that we would just say, as we make this skinnier and skinnier and skinnier, it's just an R value, and we don't have to specify which one. Okay, so the area of our strip now is 2 pi r sub I delta R. And what we've said is that what we really want is the amount of sediment that's laying along that strip. So I'm just going to call that S. And to get the amount of sediment, we're going to have to take the density at that distance r sub I, which is given by the formula, and multiply it. That's the tons per square mile. Multiply it by our area in square miles. And that's going to give us 14 pi r sub I over 1 plus r sub I squared times a delta R. Okay, so this is the tricky setup stuff, but basically anytime you're getting a constant by having everything be the same distance from the center, you're going to have to do this funny circular slices, but unroll them. Don't keep working with circles. It's much messier. You just want to unroll that so that you can work with a little rectangle. Okay, so I'm going to move over here so I don't run out of room. To get the total amount of sediment, we want to add up all the slices, starting at the center, which is r equals 0, and stopping at 100 miles, just because that's what was given in the problem. And the thing we're integrating is the thing we just wrote out, 14 pi r over 1 plus r squared dr. So we can move the 14 pi out in front. And this actually looks like a beautiful u substitution problem. If we let, I'm going to use colors so that this doesn't all run together. If we let u equal 1 plus r squared, try to make that a subscript, then du dr is 2r, or du over 2r is dr. So when I come back and put that in here, oh, I should be careful. I'm not going to put those in yet. I get r over u times du over 2r. That's looking promising. Before I forget, I'm going to change my limits of integration. So when r is 0, that's my bottom limit, u is actually going to be 1. And when r is 100, 100 squared is 10,000. So u is going to be 10,001, 10,000 plus 1. Sorry, that's a little cramped. We can cancel an r out, which is excellent. And we can even cancel a 2 out. And I'm going to get 7 pi times the integral from 1 to 10,001 of 1 over u du. And that will be 7 pi times the natural log of the absolute value of u. And then I want to evaluate that from 1 to 10,001. So I'm going to get 7 pi times the natural log of 10,001 minus, what am I going to get? 0. 7 pi times the natural log of 1. Natural log of 1 is 0, so that's actually all gone. So let me calculator in the background here for a second. Maybe. Okay, so 7 pi natural log 10,001. I'm getting, let me make sure that all looks right. Why in the world is it telling me degrees? Oh, I'm so confused. I'm using a weird calculator. Okay, so I think I switched it. I don't know why it was trying to do that. I think I should be getting 202.55, and this should be tons. Let me think about that, though. The other thing it's telling me is 11,605.15 degrees, which I think is nonsense. So we'll go with the 202.5. I apologize for not having normal technology around. I have no idea why it's doing that. But that's basically the setup. So you'll run into a few of these. You try it now, for example, where you're just going to make sure that you do a circular slice and then unroll it to make a rectangle. Okay, thanks for